Alright, now we're gonna look at question 5 part B. Find all the angles between 0 degrees and 360 degrees which satisfy the equation 10 minus 5 tangent x equals to 2 over cosine square x. Now notice that I have a tangent x on its own. But here I have a cosine square. You want to solve an equation and there's a square. I'm suspecting that there's a quadratic equation going on here. It's called a quadratic in form. Quadratic in form. Instead of solving for x square, maybe you're solving for a tangent x square. Maybe it's a quadratic in terms of tangent x. Doesn't all where you can think of the, or if you cannot see it, you can substitute tangent x with big X, and it's a tangent. It's a capital X square. Okay, I'll talk more about it as I move on later. Let's take a look. So, if I wanted a quadratic in terms of tangent x, means I want everything in terms of tangent x. What could I possibly do? What do I want to keep? Well, definitely I want to keep my 10. The 10 I want to keep. The minus 5 tangent x I want to keep. But this guy, 2 over cosine square x, this guy I don't like. I want to change that cosine square. What could I possibly do? Then I realize, oh, wait a minute, the cosine square is on the denominator. 1 over cosine x. I know what's that. It's nothing but secant x, right? One co on the one side and no co on the other side. So of course, if it's cosine square, then it will be secant 1 over cosine square, then it will be secant square as well. So in other words, what I have over here is 2 times 1 over cosine square x, but this cosine square x is nothing but secant square x. So 2 times secant square x. 2 secant square x. Correct? Okay. But wait, how does that help me? How does that help me to link from secant into a tangent? Didn't I just make things more complicated? That's when you have to recall some identities. Okay? Let me just copy and paste for speed. I'm sure if you watch my previous video that there are these 3 identities. You can just refer to your formula list. One in particular involves a secant square, and notice that it's related to tangent. It's related to tangent. So what do you think I could do next? Replace the secant square with tangent square plus 1. Right? So what I'll get is 10 minus 5 tangent x equals to 2 times of tangent square theta plus 1. Notice there's tangent square already. Just now was sorry, I used the wrong symbol. This should be a x, not theta. Okay? It should be consistent with the whatever was given. They gave you a x, you use x. If you gave you theta, you use theta. Okay? So notice that now we have tangent x single power, tangent square power 2, power 1. Just now tangent x power 1, this one tangent x power 2. So we can expand out. What do we get? 10 minus 5 tangent x equals to 2 tangent square x plus 2. Then you can bring everything over to one side. I like to keep my coefficient of the square term positive, so I'll leave my 2 tangent square alone. Leave it alone. Leave it alone. Plus 2, leave it alone. Minus 5 tangent x, bring over plus 5 tangent x. Plus 10 in front. On one side, bring it over minus 10. You got 0. Just to make things nicer. Swap them. Put my non-zeros on the left side. It's the same thing. Can you visualize this in your head? I have an iPad, I can do the swapping, but when you're writing on paper and pen, you have to manually swap it yourself. Okay, so now I have it in this form. I can continue to simplify a bit further. I have to combine the like terms. 2 tangent square is on its own. Tangent square is sort of like a x square. You can't do anything with it. It's a term on its own. There's no other tangent squares, right? There's 3 other terms. There's a plus 2, there's a plus 5 tangent x, there's a minus 10, but they are not tangent squares, so you can't do it. You can't combine it with tangent square. So you leave tangent square alone. What about 5 tangent x? 5 tangent x, same thing, there's no other terms that are tangent x. But wait, what about tangent square? Tangent square you can combine with it? No, maybe you could factorize out a tangent from both of these terms, but that is not recommended. So in the end, there are no tangent power 1 x's, so you cannot do anything to your 5 tangent x as well. So what can you combine? You'll notice that there's only one thing you can combine, which is plus 2 and minus 10 constants. Right, you can simplify a bit further. Plus 2 minus 10 is nothing but minus 8, right? Minus 8. Oh, and make things neater again, I bring this over to closer to the plus sign. Great. Now, if you still cannot see it, let's just make one clever substitution. Let capital X equals to the tangent of curvy x. Oh, what does that give me? I'll get 2x squared plus 5x minus 8. Notice I'm using capital letter X now. Not the curvy x, I'm using capital letter X. Okay, good. Now I have a quadratic. Can I factorize this? Yes, you can use all sorts of ways in your calculator, but at the end of the day, you should be able to get 2x times something and x. Sorry, I should be using capital letter. And x here, plus or minus something equals to 0. Let me just work out a few different ways. 8, what are factors? 1 times 8, 2 times 4. That's about it. Then plus and minus. What combination can I do to get a 5? At this stage, I will just use a calculator because I realized that I am very bad at doing this guess and check work. Okay, you know what? Instead, I'm just going to check my discriminant. B squared minus 4 times A times C. What do I get? 25 plus 4 times 2 is 8. 8 times 8 is 64. 64 plus 25 is 89. That's not a perfect square, so that's why I cannot factorize it. Where is my page? Yes. In other words, my b squared minus 4ac is not a perfect square. So it means that I cannot factorize out my I cannot do the factorization step over here. I will get square roots in my, if I really wanted to factorize my terms over here and here, will have square roots involved, which is bad. So we don't do that. Instead, what we do is we are going to simply use the calculator to solve it. Okay, type into your calculator and you should get 2 different answers. Maybe if you use a calculator, it might not be such a good idea because you cannot get an exact answer. You know what? Never mind. I'll just use the quadratic formula and solve it manually. Okay? Let's just do that. You can ignore the rest of the top part of the question. We'll just try and solve for x manually. Okay? So capital X is really equal to negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, you get a negative 5 here, plus minus there. And just now we already calculated is, what was it again? 5 squared minus 4 times 2 times negative 8. It's 89. All divided by 2 times 2, 4. Okay. So this 89, I don't think that there are any factors. Is it a prime number? I think it might be a prime number. I am trying to check for factors that I can divide into 89. I've tried up to prime numbers up to 17 so far, and I don't think there are any. So 89 is a prime number. I'll just leave it alone. So I will just leave it alone and write down the square root of 89 and leave it. So now I will have 2 answers. I will have x equals to negative 5 over 4 minus square root 89 over 4, or x equals to minus 5 over 4 plus square root of 89 over 4. These two as my answers. But just a quick check with your calculator, using your calculator to try and solve the quadratic equation. Coefficient of x squared is 2, coefficient of x is 5, constant term is -8. Enter, and I get 1.108. This guy is approximately 1.10849, and I truncate, meaning I just copy down the 9. I don't think about rounding up or down. I just ignore the digits that come afterwards. 1, 2, 3, 4, 5 decimal places, and I truncate. And for your negative answer, it will be around -3.60849. Truncate, I don't care, round up or round down, just leave it alone. And just take 6 of the numbers that come after the decimal place and ignore the rest of the digits. Now, two cases where two different cases here. You have x being negative or x being positive. We are not done yet because this is a capital X, and at the very beginning we were trying to solve for a curvy x, which is in terms of tangent x. Right, we made this substitution, don't forget. So now what we have to do is we have to substitute back. So we get tangent of x is equal to this, or tangent of x is equal to that. This guy being negative and this guy being positive. Now that means that we have, and both are acceptable solutions. Why? Because we are looking at tangent x. Remember, tangent, actually in any sine, cosine, or tangent, you can have both positive and negative values. In this case, how do you solve for x when you're solving an equation like this? Must recall, what you do is you simply write down basic angle, or you can also call it reference angle. Or if the question hasn't already choked, they haven't used up the variable alpha to represent something else, you could just simply write down alpha. If you can't remember the English words basic or reference, never mind, just write alpha. Draw a fish. Okay, draw a fish, but don't draw a fish, draw alpha. It's alpha. If you really struggle to remember the English word, never mind, just write alpha. Alpha represents the basic angle. If you understand the idea, that's good enough. Now in this case, tangent x is equal to this value over here. What you want to do is you're gonna go into your calculator. You're going to type in in a calculator only. Let me use a different color to represent calculator what you type in. Type in tangent inverse. What do you want to type after tangent inverse? Right, make sure that you are in radian mode, by the way. Tangent inverse, and then hold on, actually no, sorry, make sure you're in degree mode, because the question required you to answer in degrees. So we'll try to get an answer in degrees straight away. Use degree mode, make sure you're in degree mode. Then we're gonna integrate the tangent inverse. We're going to find what is our basic angle by using tangent inverse. Okay, tangent inverse of this quantity over here, you notice that we already roughly know that it's -3.6, right? But in the case where we are looking at tangent inverse, what we have to do is we have to ignore the sign. Okay, when we are trying to find the basic angle by using the tangent inverse in the calculator, by using the calculator's tangent inverse function, we will always want to use the positive version of whatever value we're trying to take the inverse tangent of. Alright, so in this case it's -3.608, so we want the positive version. So what do we have to do? What we have to do is we have to take this quantity, go and times a -1. What do you get at the end? You get a plus 5 over 4 and a plus square root 89 over 4. So that positive version, which is really just approximately positive 3.60849 dot dot dot. This guy is what you have to type in the calculator. Type in the positive version of the number. Ignore the sign, SIGN. So what I'll type in is tangent inverse of, wow, the palm rejection is not very effective today. Okay, so what we want is tangent inverse of 5 over 4 plus square root 89 over 4. Type that into your calculator. Tangent inverse it. And then you should get a certain answer. Let's take a look at what's the answer. Oh, you realize it is 74.5106 degrees. Okay, I'll just keep it as that. Then that's when you go back into your answer and you write down 74.5106 degrees. You don't need to write down the tangent inverse. You don't need to write down the positive. You just need to write down the final answer, 74. Okay, can so now, so type in I'm just gonna copy this format over. Now I deal with the second case of the tangent later. But now that we have found the basic angle for the first guy, which is 74.5106, we have to consider what is the possible angles that x is in. The possible angles that x is. Okay. Now in this case, you have a tangent of x being a negative 3.60, which is a negative number. Currently we have tangent of x being less than 0. So you have to recall ASTC, add sugar to coffee, or you can think of it as all science teachers are crazy. Now in this case, you have tangent t in quadrant. This is quadrant 1, 2, 3, and 4. That's the terminology. Oh, why is there a purple line here? Yeah, quadrant 1, 2, 3, and 4. Then the t is in quadrant 3, which means that, and the A here represents all. What this means is the quadrant 1 angles and quadrant 3 angles will have positive tangents. But now we want negative tangents, right? Negative tangents. So it means that we don't look at quadrant 1, we don't look at quadrant 3. Instead, tangent x being negative will mean that the angle x is in quadrant 2 or quadrant 4. Okay, it has to be in quadrant 2 or quadrant 4, right? Based on ASTC. So it means x is in quadrant 2 or quadrant 4. Which means, if you can recall, remember your ribbon, your bow tie, this one. Here is your angle. Here is your angle. The basic angle here is a basic angle. Here is a basic angle. Okay, I'll just zoom in a bit. This guy is quadrant 1 angle. This guy is quadrant 2. This guy is quadrant 3. And this guy is quadrant 4. Okay, you always start from the positive x-axis and then you go anti-clockwise for positive angles. Okay, let's just remove all those and just focus on the relevant, on the, how do I undo this? Undo, yes. Oh no, my eraser is too big. I need to change to a smaller size. Erase, 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 erase. Okay, now what I want to focus on is on the quadrant 2 and the quadrant 4 angles. So what I have is this guy over here and this guy over there. How would I find those two angles based on this picture? Very simple, very simple. Quadrant 2, okay, I'll use a different, okay. The palm rejection is not working. Or am I accidentally pressing with my finger? Okay, anyways, quadrant 1 is this guy, right? So we'll take a look at what is this angle. It's nothing but, notice, it's just taking, it's like you're taking this arrow. You start off from this positive side. You rotate 180 degrees like this. And then you go clockwise by a little bit. And that little bit is your reference angle. Okay? And what this means is when you rotate clockwise, I start again. Start from positive x-axis, you go rotate anti-clockwise 180 degrees. Then you rotate clockwise by a little bit. When you rotate clockwise, as you rotate clockwise, you're adding angles. Okay? You're subtracting angles. Okay, the angle as you go clockwise is negative. Okay, this one as you go from positive x-axis, you go anti-clockwise. This is a positive angle. But if you go clockwise, and from here until here, it's a negative angle. So what this all means? What does this all mean? It means if you can visualize from this ribbon only, quadrant 2 angle, right, will be very simple. It is just x equals to 180 degrees. You rotate from here all the way to here, and then you go back a little bit. Go back a little bit, I have to minus, right? Go back a little bit. Sorry, let me try that again. When you go back a little bit, you have to minus a certain angle. And what is that angle? It is your reference angle, 74.5106. Okay? Can so I'll just use the approximation already at this stage. 74.5106. I think it's long enough. I will get 105.4894, and at this stage actually I should have used a approximation sign, approximation, and then finally I will want to end off with a 1 decimal place approximation. So draw a line here, 8, round up or down, up, right? So plus 1 to the 4 becomes 5 degrees. That's your quadrant 2 angle. But how about your quadrant 2? What about your quadrant 4 angle? So quadrant 4. Let's draw this again. Quadrant 4. Very simple. It's nothing but this side here. You want to go from you want to start from this positive side. You go anti-clockwise until you reach this quadrant 4. How do you do that? Very simple. You just have a. Let me just introduce an extra line like this. So from the middle, go all the way to the right. And then what you want to do is you want to start from here. Remember, from positive x-axis, you go anti-clockwise. Anti-clockwise. In this case, anti-clockwise. Do you want to stop here? 270 degrees? Or you try again. You start from positive x-axis. Positive x-axis. You go anti-clockwise 90 degrees. Do you stop here? No. Continue, right? You haven't reached. 180 degrees? No. Haven't reached. Continue. 270 degrees? Almost, maybe. But do I do 270 degrees then plus a reference angle? Is this side here the reference angle? No, it's not. What you're supposed to do is you're supposed to reach 270, don't stop there. Continue all the way to 360 degrees. Then you add back clockwise this amount that I'm sweeping out. Okay, start from you start from the right side, you go anti-clockwise 360 degrees, then you go clockwise by a little bit like this. Okay, I hope this animation helped a little bit. Helps you to visualize this. So basically what you have is you have an arrow that starts from this side, you go anti-clockwise by 360 degrees, and then you go back a little bit by the reference angle. That's how you visualize it. That's how I remember it. I don't memorize, quadrant 4 must be 360 degrees minus reference angle. No, I don't remember this. What I remember is a picture. You start from the clockwise, you go anti-clockwise, and then you think of a smart way for you to land on the correct position. I memorized the position. This is quadrant 4, right? A line that is in quadrant 4. That's quite obvious, Then after that, you think, okay, I also memorized. You must always start from. Oops, I erased it. You must always start from the positive x-axis, and then you go anti-clockwise. I also have to memorize that you go anti-clockwise. But from then on, I don't memorize anymore. I memorize so many things already. Why do you want to memorize another extra thing? Don't need to memorize. What I do instead, is start. Eraser. What I do is I think about it as starting from the positive x-axis like this. Then I go anti-clockwise 360 degrees, and then I go back by a little bit of the reference angle, so that I can land on this line. Go back by a bit. Okay, so anyways, how do you get the quadrant 4 angle? Let's drag this away. Very simple. It's nothing but you start off with x, it's approximately equal to 360 degrees. Remember, I added the full rotation, 360. Then now I have to minus off, because I exceeded the angle already. I exceeded this line already. I have to add back a little bit over here, add back a little bit over here. And what is that little angle I'm adding back? It is nothing but the reference angle, 74.5106 degrees, which is approximately equal to 360 minus 74.5106, which gives you a 285.4894 degrees. And then this will be equal to 285. I want to round off to one decimal place. Oh, right, I have to write down 1 dp. Yeah, I rounded off to 1 dp. Now, 1 dp is this guy, but then I look at the digit that comes directly after 8. Round up or down? 8. 5 to 9 you round up, so 8 is round up. Up means you have to plus 1 to 4, so it becomes 5 degrees. Done. Write down 1 dp at the end, and then if you want, you can write down a Q4. Honestly, this is optional. Don't need to write down Q4. Don't need to write down Q2. If you want to write down, it's also okay. But most important is to remember to write down 1 dp. To tell the examiner you're rounding off to 1 dp. Okay, then how about the next part? You have tangent x equal to -5/4 plus square root 89/4. Same thing here. We already approximated it as 1.108, which is a positive value. So we don't need to do anything funny like times a -1 as previously. We don't need to. We can just take it as 1.10849. Then we, inside our calculator, make sure it's in degree mode. Same thing. Make sure it's in degree mode. We go and type in. Make sure it's in degree mode. We type in tangent inverse of something. What is that something? Sorry. Very simple. It is just this quantity. Shrink it down. Right over here. Whatever we've already figured out as the value. So you just take tangent inverse of -5/4 plus square root 89 whole thing divided by 4. What do you get at the end? You will get 47.9456 degrees. Good. Very good. So now this is our reference angle. Reference angle equals to 47.9456 degrees. Okay, good. So what this means now, I'll just delete this. I'll go use back my nice little picture. What I want is I want to figure out what are my angle x. But in this case, this is a positive value, right? So positive, what would you expect if you use ASTC again, add sugar to coffee? Positive value means that the tangent of whatever angle, the x, has to be in the quadrants that allow tangent to be positive. And straight away I should know it's quadrant 3 and quadrant 1. So quadrant 3 angle and quadrant 1 angle. Quadrant 1 angle, don't need to think, it's just the angle itself. So x is equal to the reference angle, 4.9456. Then you round off, and then this is an approximation already, right? We never write down the full decimal place. We can't, there's infinitely many. So you just have to write down the approximation, estimated, curly sign. And then finally it's exactly equal to 47.9 degrees. Round off to 1 dp. Why is it 9? Because the 4 is under h. 0 to 4, you cannot buy 4D, you cannot go queue up. Under 18 cannot go and buy. So you have to plus 0. The 9 plus 0, then you're just left with a plus 9. It's 47.9 degrees. Okay? Good. That's one of the angles done. That's our quadrant 1 angle done. So now we need to deal with our quadrant 4 angle. Quadrant 3 angle. We have to deal with our quadrant 3 angle. Let's take a look. What is our quadrant 3 angle? Nothing but x equals to, let's just visualize it again. Again, I have my, okay, maybe I should use a different color, or at least erase off the picture a bit. Just redraw it. Start off with the positive x-axis, then you have this quantity over here. Then, sorry, I mean, you have this line which is representing the positive x-axis over here. Then you want to go to quadrant 3. How would you do that? It means that you have to end up over here. Oh, you have to end up over here. How do you do that? How do you do that? Very simple. You just have to rotate 90 degrees. Is that enough? No, continue. Rotate anti-clockwise, so it's a positive angle. Rotate until you reach 180 degrees. Is that enough? No, not enough. You still need to rotate a little bit more. You see, this is this region here marked by which is inside the ribbon. That's your reference angle, right? So you have to continue rotating your pink line a bit more anti-clockwise until eventually you reach your orange angle. And how do you do that? It's very simple. You just start from here, 180 degrees, and then you add a little bit more, which is your reference angle. Right? Can you visualize that? It's starting from the positive x-axis. You rotate anti-clockwise 90 degrees. Is it enough? No. Continue. Do we stop here? No. Do we stop here? No. Do we stop here? No. Do we stop here? 180 degrees? Almost, but still no. Continue. Anti-clockwise until you eventually reach your orange angle. But take note that a special formula you can use now is 180 degrees plus the reference angle. Of course, please learn to visualize this instead of memorizing it. So x is now nothing but 180 degrees plus that tiny little angle that we added, which is the reference angle 47.9456 degrees. Right, this should be an approximation, not equal, because this 47.9456 is not an exact quantity anymore. So it's not exactly equal, it's an approximation. So now but the next step we can write down equal. Why? Because we are going to round it off to 1 dp. We are telling the examiner this is equal to an exact approximation. Okay, it is an approximation. That's why we put equal sign. Okay, so now 180 plus that answer, 47 something, and you'll get 227. Okay, just type in your calculator. You'll get 227.945. Okay, 94 means that you should get. Okay, I'll just show one extra line of. Okay, I'll just show one extra line of working. It's approximately equal to 227.945 degrees, and which is then equal to 227.9 degrees 1 dp. Okay, the extra line is still an approximation, so that's why I use approximation sign, but the next very last line I put equal sign because it is exactly equal to 1 dp. Okay, good. So now we have all 4 of our angles. Then double confirm with the question. They wanted you to find angles between 0 degrees and 360 degrees. Do we have that? 105.5, yes. 285.5, yes. 47.9, yes. 227.9, yes. They're all within 0 to 360 degrees, and that is all 4 of your answers. All 4 of the angles that you need. The angle x. Oh.